Hi, Jessica. I was wondering, I'd like to dig down a little bit into some of the assumptions. For example, how do you decide when you're going to be when the electric vehicle is going to be driven as opposed to the gasoline vehicle? Is there a cost there? And also on the specific energy, does that affect the range in the car? Or do the vehicle parameters depend on the specific energy? Do you design a car with more battery, for example, if it's more compact?
So this is really based on, this is a model, as I mentioned, it took us, actually it was more like 5 years to build in my group, and it's called the trip energy model. What's that?
Oh, I got it.
Okay, yeah.
It was caught, it was captured.
Anyway, don't worry.
No worries. I can send I mean, it's coming out next week, but I can send it if anyone's interested. So we know, actually the trip energy model can do all sorts of things because we actually know when people are leaving, what they're doing, what their trips are being used for. We're actually developing a couple of apps based on this model. These results here are just based on asking the question, what percentage of gasoline, first of all, what percentage of vehicles could be replaced by a below average cost electric vehicle. So below average meaning below the average cost per mile of the 150 most popular vehicles on the market in the US today. What percentage could be replaced by this below average cost electric vehicle if I can only charge once a day? So for example, at night or maybe at the office. The trip energy model, so the trip energy model has a, demand model. So that's where we reconstructed the second by second driving behavior based on combining different kinds of data sets. So you have GPS data sets, you have survey data, they have different geographical coverage, they have different levels of resolution. So we take the best of all, put them together. We have a vehicle model, which is a reduced form model that reproduces the EPA's fuel economy test, but we can look at fuel economy for very different drive cycles. We're not just looking at 2 drive cycles. And we have a temperature model as well in there.
Great.
Yeah.
So you have a collection of electric vehicles that correspond to ones that are out there, and say if a gasoline vehicle owner wanted to pick one of these.
Right. Well, we have, so we had to model the internal combustion engine vehicle as well as the battery electric vehicle. So we now have about 1,000 vehicles in the model. These results are based on just simply that one below average cost electric vehicle. But, future work will look at,
Thanks.
Yeah.
Let's go down here and then
Oh, and sorry, can I just say one more thing? In the context of climate change mitigation, as Inej mentioned, the benefits of going to hybrid or electric vehicles varies across different locations. This is actually something we've been working on as well, but and using some of Inej's, building off of some of Inej's work. But basically, if you take the 150 most popular vehicles on the road today, there are a number of electric, battery electric, hybrid electric, plug-in hybrid electric vehicles that meet the 2030 emissions reduction targets for the US. And if you want to get to the 2050 target, you need to electrify, unless other fuels become available, or, and this could be hydrogen, but you need to electrify transportation. That rate of, the rate of, and you have to decarbonize electricity, but the rate of decarbonization required for the electric sector alone is faster than the rate that you would require to meet the emissions reduction targets of the transportation sector if you apply equal percent reductions across both. And so that is another paper, if you guys are interested, we're developing an app that will be released with that paper to bring the information. So.
Jessica, I was curious with the performance intensity equation, how important it is in terms of attracting investors. If you look backwards in time, like 40 years ago when there was a technology investment kind of choice going on, as for surprises, like it works most of the time or it works half the time, how does it kind of hold up over time when you look in the hindcast sense?
So I mean, I've done a lot of work on why some technologies improve faster than others, why some show noisier trends, how we can describe those trends with equations. how noisy, like what's the stochastic part, what's the deterministic part, what are mechanistic models for why we might see one trend or another. I think you're asking on what basis do investors decide between technologies? What I will say is that we've started to look at this a little bit in terms of cost riskiness. So it's not just the expected cost that investors care about. And I haven't done any kind of survey of investors, but this is kind of more in the theory stages, and we'll be actually doing some experimental work on this. But they don't just care about the expected cost, they care also about the risk, or the uncertainty part of it. And so, this also relates to my comment this morning where I think, again, I haven't looked at this in any kind of scientific way, but I think, if we look at uncertainty and costs, and maybe with larger unit scale technologies, there tends to be more uncertainty just because you have a smaller number of data points. That's something that is factored into investors' decisions. Also, what is the upfront investment required? This is the example we all know in comparing natural gas and coal. That also matters. So these are, that cost number can be a kind of devious thing. Like, we have to think carefully about what those costs are and not just think about a single number, but also the variability over time, across space, that kind of thing.
More of a observation, and you can comment, than a question.
Yeah.
And that it almost seems like your battery case is a microcosm of this broader problem, and that a lot of these problems have the commonality that as you get to higher and higher penetration or higher and higher battery sizes, that the amount of additional investment per amount of additional gain gets really high. And so at some point, some alternate technology or approach becomes more attractive. So maybe at a certain point with the power sector, you switch to demand management. And so maybe here, at a certain point, you rent a fuel cell car that can go long distances.
Yeah, I think it really depends on the technology and the service that you're providing. So there's other work that I didn't have time to talk about, but basically, we have in mind the abatement cost curve, where reducing emissions more or higher levels of abatement cost more per unit avoided or per unit abated. That's kind of a mental model that we have. But in some cases, for some technologies, and photovoltaics is one, and I noticed nobody's been talking about PV, but I'm happy to talk about it or not, but I've looked a lot at that. That's one where the rate of improvement has been rather high, and it's been sustained over long periods of time, such that that curve kind of goes in the opposite direction, in the sense that, for some technologies with very rapid rates of improvement, it's plausible that as you cut emissions, the cost of doing so decreases. This is something that went into, that I wrote quite a bit about in the fall ahead of the Paris meetings, and sort of tried to bring that. That's based on, so it also points to a policy takeaway, which is that policies encouraging deployment are very important. And this is something not based on regression analysis, but looking at exactly what it is about these technologies that's improving. But absolutely, I think in this case, for the battery electric vehicles, it does look like some other, and it's maybe not another battery, although we can always be surprised, but or if they get really, really cheap, as I was saying, then it changes things a bit. But in this case, I think it does argue for a different kind of basically storage option, maybe a liquid fuel, maybe something with a higher energy density, or somehow cheaper and easier to kind of refill to sort of come in.
So we have about 5 minutes left.
Okay, I'll try to keep the comment short.
Be very quick. On the vehicle study, do you account for two potential confounding variables? The first being the low percentage in major cities of cars that are actually garage parked and therefore could be charged at home. San Francisco, it's less than 20%, I understand. Chicago and New York, same thing.
Right.
So they're not just because you have the car doesn't mean you have the value in
Yeah.
it if you can't plug it in.
Yeah.
And the second thing is the weather extremes. Minnesota in the winter, different range a lot.
Yeah,
Phoenix
yeah.
in the summer, leave it out overnight, the whole thing will self-discharge
Mm-hmm.
at the airport. Do you put in these kind of confounding variables into this, or this is just a blanket one-size-fits-all?
Yeah, no, to answer the second question, yes, we have a temperature model that takes into account hourly temperature variations across different locations. And so it's interesting that some of the effects balance out such that that number is similar across different cities. The charging infrastructure, I mean, the assumption here was that you can only charge once a day. That could be at home, that could be at work. That 20% number, I don't know if you guys have looked at what the number is. I haven't looked at what that is. That might sound, I mean, I think if we added workplace charging, that would go up. And what's that?
In a major city, I'm not sure if you work in an office building, you know, versus.
Right.
I'm not sure it goes up.
Yeah, I mean, it may not, and you know, that's something that would act to reduce these numbers. Being able to charge at work could, you know, boost some of these numbers somewhat, although those may not be the longest distance trips. So yeah, I mean, those kinds of, you know, this is sort of quantifying what is the number based on this picture of how people are driving. What could it be? But there are all sorts of other issues that have to be solved, like would someone buy an electric vehicle if it can only meet their needs on 9 out of 10 days? Probably, maybe not. Maybe they would if they could order a self-driving car to show up at their door and they could predict when they would need it, which our model is designed to be able to do because this is a probabilistic view of range. You know, then maybe they would, you know, but, you know, the charging infrastructure, you know, it's interesting, the reviewers' comments, some said too conservative, some said not conservative enough. So it's tricky to say where that would come out, but it's certainly a consideration, yeah.
So you said that the curve of how good batteries need to be or whatever is consistent across cities, but what across cities in different countries? So I mean, I live in London and I haven't owned a car for 5 years.
Yeah.
And I'd also say that actually in terms of climate benefit, one of the things that would really help would be to get people out of cars and onto bikes.
Mm-hmm. Yeah.
Which is what we've been really trying to do in London recently.
Yeah, yeah. Yeah, so on that second point, actually I have an ARPA-E project where we're developing an app. I never thought I'd be developing apps. I don't know why I'm developing so many apps right now, but it's just happened. But to reward people for energy saving choices, so to reward that kind of shift. And basically local businesses would buy into it to provide, you know, services and you can get discounts and things like that. But that involves modeling the energy consumption across an entire city, and that's like a big collaborative project that we're pursuing right now. But the first question, I don't know the answer. I don't know how similar this is across cities. When I started both of these projects, international cities, we just looked at the US so far, but when I started both of these projects, I thought maybe the answer would be, you know, by understanding how people are consuming energy across different locations, we would get to different targets and different technologies that would be, you know, different technologies would be favored in different locations. And it just so it turns out that that's not the case based on these two studies. I think it has to do with constraints like the diurnal cycle, how people spend their time throughout the day, speed limits, things like that. So some of that could change. Certainly the, you know, the per capita car ownership would change across different cities. That's not what we looked at here.
So we have just a couple minutes left. Maybe we can queue up a few of the questions.
Yeah. I'll try to be quick, sorry. Yeah.
So my question relates to something closely related to cost, which is risk in deployment of new technologies. And I'd mentioned earlier that for advanced light water reactors, conventional reactors, the warranty that you get from GE or Westinghouse or Areva is really lousy. Mm-hmm. And one of the questions is, how do you better manage that risk if you have access to ability to collect much larger amounts of data, perform high fidelity simulation? And automobiles today, the quantities of data that are being collected during the operation that can be made available are
Yeah.
enormous. So a couple of things we've been working on, I'm curious if there's other ideas as well. One is that we've been looking at how to perform simultaneous real-time high-fidelity simulation of integral effects test facility that we have while we're running it, so that we can identify deviations from expected behavior at much lower levels than an operator could, and therefore perhaps catch things before they cause failure. And then another is the whole area of documenting, so when you do have failures, your corrective actions and your root cause analysis can be effective. And so we've been deploying Google Nest cams. Whenever we assemble an experiment, we try to record exactly what it was we did, so that if we have to go back and figure out why the experiment failed, we have a base of data that we can refer to, so that we don't have to necessarily disassemble the thing. I'm curious if there's a line of research that's looking at better strategies and ways to manage risk and provide better warranties.
Well, I mean, I don't know about on the business side, it's not really my area, but I mean, I will say that one of the motivations behind this vehicle work is to bring information to investors' fingertips. Investors in this case would be private citizens, so that they can make decisions based on all of, on the best information. And I think when I've shown, I didn't show it here, but we have this cost carbon space showing different technologies. People like to see that because they can find their car on there and they know exactly, what the costs are, the carbon emissions, things like that. So I think that, my hunch is that in the area of nuclear fission, I was thinking about this when you were talking, that I think the industry maybe would, it would be a good idea for the industry to really push for, I know people have been pushing for more transparency, but even if, let's say, the risks of cost overruns are high, right? Or the risk of, occasional failures are, there is a non-negligible risk there. Having that information may actually encourage investment. I think there's this kind of perceived risk among investors and a limited data set. And I think they're more sophisticated sometimes than we give them credit for. Again, this isn't my, area. I've not, looked at this in a scientific way, but I have been thinking about metrics for evaluating technology. So I think that could be a strategy that could be helpful in that domain as well.
So we have three more I think we have yet.
Okay.
With your indulgence, could we queue all three up and then
Yeah.
Right.
let you have the final word?
Great. Try to make it quick. So I love the plot that shows that you can overdo it, right? But the specific energy axis is very good in this case for batteries. I totally understand why you do it, because ARPA-E put that target out there. But if you want to be able to compare different technologies, for example, fuel cells would be way off that chart anyway, and it wouldn't tell you very much. So you have some other assumptions in there, and I'm wondering if it isn't really the horizontal axis that you really want isn't range per dollar or range per mass or range per volume, right? And you can have different values, so I think specific energy kind of buries what you're really after. It seems.
Yeah, it's basically battery capacity at constant cost.
Yeah.
And the y-axis,
So
the
it's range per
behavior is determined by how people are driving, so that we can compare range requirements to range constraints. That's basically what it is.
So it's range per dollar, right?
Yeah, we can. I mean, not really, because I'm only looking at one car, which is an affordable car. Not everyone can afford a Tesla, sadly, but this is an affordable car. It's like a Ford Focus electric kind of car. So there's a cost assumption there. So if you looked at higher costs, it would be a different plot. You could get much further. You could replace more cars, but not everyone can afford those cars.
Yes, I was going to comment similarly that I like the idea of performance being the metric or being the axis upon which you'd measure the effectiveness of this. But yeah, and I was just going to comment as well that we were talking about how much of a difference does multiple charging locations or all those kind of things. I don't know if there's a literature on utility factor in hybrid vehicles and plug-in hybrid vehicles that answers some of those questions. So that might be have some of those answers for you in there. The only
Yeah, I mean, the key gap that this fills is to understand how people are driving and how, and then how vehicles perform and batteries perform relative to that.
yeah. Okay, yeah, I'll leave it.
So what's the real, there's a key piece missing in modeling like that, which is of course consumer preference, right? So so let's ask the question, I think again, which is, can the effectiveness of those tools help us with directed research, et cetera? But also, how do we incorporate actually consumer preference and choice preferences and things like that, that from your initial graph of the, kind of attractiveness of batteries for gasoline substitution potential, Tesla or any other EV actually represents a complete case that's not on your map, I think, right? I mean, it says today's current batteries are eligible or are able to displace 100% gasoline, right? And so that doesn't get captured in a pure economic model, but it gets captured in a consumer choice model. And so
Well, they can't, because not everyone can afford
depends
those
on
long-range
the
electric
service
vehicles.
offering and the finance offering and things like that.
Well, no,
I mean, so
not-
you're thinking of
No.
you're thinking of
I mean,
all
this-
populations?
This is, I mean, each of these papers asks a very specific question, and it doesn't answer all questions one might possibly want to ask, right?
Yeah, well.
But the specific question is, for an affordable vehicle defined as a vehicle that is a below average cost vehicle as compared to the 150 most popular models on the US market today, if I replace, how many vehicles on the road can I replace on an average day, and what percentage of gasoline would that displace? And the key innovation there was to be able to, which we didn't know we'd be able to do ahead of time, reconstruct the second-by-second driving behavior of millions of people across the US and all US cities. So that's, but absolutely, I mean, understanding why, and then the cost carbon space one is again, providing information on costs versus carbon. People seem to respond to it, but I've not yet done the survey on what people would respond to most. I'm collaborating with some behavioral economists and actually also collaborating with Ignatius' brother on some of these questions. So yeah.
So a very quick reaction to this point by Doug, which is really important. It's really a fascinating question, and it's a complicated one because you have three things. You have the choice for the vehicle, and there we can indeed use choice modeling to look retrospectively at the choices that people have done over time. But we're here talking about models that are not yet in the market. So how the hell do you model those is really tricky. So you have the retrospective studies that can inform you a little bit. You have the forward-looking models based on stated preferences that we know don't reveal the real preferences when the vehicles come in the market, so they can only tell you so much. And the third problem is really the distinction between two choices, the choice of the vehicle and the choice of the fuel, right? And so one of the things, those two are interconnected, but one of the things that we're doing right now is to try to isolate the fuel choice effects. So we did an experiment with stated preferences saying, imagine you have a vehicle that could use either of those fuels with those different attributes, and trying to understand how people select from natural gas versus electrification versus gasoline. So, yeah. So thinking about numbers, it seems like just looking at this is absolutely mind-blowing that China in 3 years used more cement than the United States in the last 100 years. So this is really enormous, and it will still compare with Europe more unfavorably. So my question is, are you aware whether someone has looked really carefully at the cement and other material used in different cities? Because the buildings themselves and the way of developing the cities is tremendously different, right, on the materials for construction, and that may really play a role. Are you aware if someone has looked at that in more
So
detail?
I haven't worked on construction. I just we had the discussion on cement and steel, so I thought I would look for data on that, because I had seen their article saying China is using tremendous amounts of cement. But maybe that's an interesting research question.
I also know
said, I've worked some with Karen Cito at Yale, who's looking at a lot of those questions of urban form and if we can design these things from the outset in a more environmentally friendly way. But she has papers even.
So I'm really happy to hear you bring up the point that we really do need to begin thinking about the developing world, where so much of the future emissions are going to potentially be or not be, depending upon how the economic development. I wonder if you would care to comment on, it seems to me that the first priority in the developing world is development. That is raising the standard of living per capita. That climate change control would be really great, but the very first priority is economic development. How does that shape the technology needs, or how we approach the technology development and deployment in developing economies, as opposed to the highly developed economies in Western Europe and North America, or Japan, for example?
So I don't have great answers for all of these questions, but we did, that is one of the questions, for example, with mini grids, which we have talked about, is mini grids in Africa are growing, and they're mostly solar based with storage, but there's a question of whether they can actually provide enough quality electricity to support development. So we need to understand that. We need to understand which technologies could support economic development. And yeah, I mean, those countries are not thinking about CO2, right? A lot of those, and those are a lot of the problems with the negotiations in the climate agreement, is what are their allowances. But that's why we as academics can start thinking about those technologies and how they fit with the goal of economic development. So the project I'm going to be deploying when I go to Rwanda is to monitor mini grids, do system performance monitoring to see if they're actually providing the services that they say. So is the quality of electricity good? And then tracking outcomes, community outcomes. Is it increasing economic opportunities and economic activities? Because we don't know that. But I don't have great answers.
And how are those mini grids powered?
They're solar hybrid systems. So they have solar and storage, but sometimes they have backup diesel. Diesel is very expensive in some areas of Africa. So Africa does have that benefit that energy is currently more expensive. I mean, $1 per kilowatt hour to charge a phone. Oh.
Two questions, and one actually dovetails like this with Jay's point quite nicely. And it's just, I think, the basic question of, can the scaling relationships be different as sub-Saharan Africa, for example, moves from current penetration to a mode that would actually enable strong economic growth? And it just seems like the theme that comes up again and again is that for some of the world's poorest right now, renewable energy actually is a big plus, because if you want to go to a village and you just need a light or charging a cell phone, that's a mode that's actually cheaper and easier than implementing a whole grid. But the next question for scaling is, well, can you power a whole economic center in a city? And that won't work based on just one-off renewables. And I think it seems like the question around transport is very similar. One motorcycle in a rural village is transformational, yet that's very, very far from the economic trajectories that need to happen. And I guess that was more a point. My other question is around your cost point, and how you basically were emphasizing that because in so many places the costs per electricity are really high right now, that actually creates some interesting questions around what criteria are used through the development banks. And I guess I was hoping to hear your perspective on some of the approaches like the World Bank has taken, where they actually do make they're not going to say they will never build coal again, but they screen against it. World Bank obviously is only one of many players, and it can be a quite controversial one. So how do you see the criteria where those ethical choices that Jay raises make sense, and do you see more innovation in that space?
So the problem, and what you see, and this goes back to something Jessica said, what you keep seeing is that the World Bank, the African Development Bank, they're not enough to meet the needs. There has to be private investment participation in these systems. And most of the activity on mini-grids has been around they're private companies that are just, they're for-profit private companies. For them, the biggest thing is cost and the risk, the financial risk, because so there is evidence that customers are willing to pay $1 per kilowatt hour to charge their phone. But if you're a mini-grid owner, you need to have, if you're looking for finance, you need to know that your risk is going to be low. And these are poor customers that may not have continuous ability to pay their electricity bills. So that really affects their ability to raise capital and actually deploy these systems. So for all of the technologies that we discussed, I'm an engineer, so maybe I'm like an optimist, but I think the engineers can eventually figure out a lot of the technical issues with all of these technologies. The big problem is cost, and how do you bring that cost down? Because right now they may be willing to pay $1 per kilowatt hour, but that's not always going to be the case. So how do you scale up and reduce costs? I don't know if that answers your question.
That's great. And could you just comment on how you see private investment within Africa as compared to developing?
So the conventional utility, so South Africa has a large publicly owned utility. And their model is grid expansion, and they want to do grid expansion through all of the continent. But the most activity happening on mini-grids are privately owned mini-grid utilities that are independent, and you see it's like European and American people, young people that are passionate about these and see an opportunity to do something, but also they see it as a financially viable option. So a lot of it is private investment, like startups, not the traditional investor-owned utility model that we have in the US with large power plants, because the ones that are building the large power plants are government-owned.
It's really important to highlight this, and I agree with your assessment that 100% of the last 20% is this stuff. When we think about the energy component of sustainable development, there are three fundamentally different models you can think about that people have discussed. One is the leapfrogging, the idea of you go straight to the cell phones or straight to the solar. The second is that most of these regions are going to need one or more generations of fossil in order to move themselves far enough up the development trajectory that it makes sense to start deploying renewables. And a third is essentially a subsidized system where the transition to renewables occurs immediately, but with financial subsidies from the developed world. And I wonder if you can comment on, from your experience, how the development community is thinking about these three options, and whether you think from the perspective of the sort of the technology folks around here, there are particular things that ought to be kept in mind and make any of those three options either more attractive or really dead ends.
So my experience is very limited, which is why I'm going to Rwanda for a year. And maybe see if you can pitch in here. From the little discussions I've had with people actually on the ground, I think there really is a lot of hesitancy about World Bank coming in and financing big projects and then leaving. There's a lot of concern about that being sustainable in the long term, particularly if there's no human capital investments as well, and learning how to operate and build those projects like domestically. So my sense is that a lot of it will be through private investment and incentives for private investment. Do you have?
Yeah, I can respond on a couple dimensions. One, I think it's not right to assume that Africa is going to have to go through one or two cycles of using heavy carbon intensity electricity because the main thing cost of financing. The opportunity in a number of countries to actually use fossil fuels is limited, so there need to be alternatives for them in any event. In some it's high, but in some it's low. And I think when you start to look at driving economic activity, you do have to have certain levels of power in order to do that. But there's probably going to be a hybrid model that says, for example, in Rwanda, literally 30% of the population being electrified at least in the next 10 years by standalone solar, some fraction in mini grids, and the rest in grids to get to 100% by, say, 2020, 2022. If you pick other larger countries, what you're going to see is more mini grids coming in, and the challenge of trying to get from what is 80 cents to $1 a watt right now power. But there does appear, in my mind, to be a roadmap to get that number down to, say, 30 cents a kilowatt hour. It's not clear that you can drag a transmission line all the way across Tanzania to different villages and beat that number. So I would actually posit that what the Western world needs to do in trying to support Africa in sustainable development is to think very hard about what's the right mix of technologies that are available today and can become available in the not too distant future. And in Africa, the horse is out of the barn. Things are being funded right now, to your point, not necessarily particularly in a coordinated or systems perspective. And what we can really do is help make sure that the blended mix of what goes in is on a roadmap to continue to bring down costs. But if you look at the sort of human happiness or human sort of welfare index versus amount of power you need, a small amount of power goes a very, very long way. So, I think there's a chance here not to make Africa once again the experiment of the Western world, but to very proactively help run these experiments, quote unquote experiments, right now. And the one thing I would sort of say, Paulina, in your work, is marrying your academic work with what is actually a big experimental cauldron that's going on right now, regardless of whether or not you're there, is really important, because if we don't have feedback going into the system on the order of months to a couple of years, this is going to be a done deal in many, many places, although it's going to take a decade to electrify a bunch of the countries. So right now, I'd say the time is of the essence.
By the way, I'm not building mini grids. I'm just partnering with mini grid developers.
I would want to stress, though, the fact that right now it's the deplorable situation that somebody has to pay $1.20 while dirt poor is not an excuse to say we can stick you with the 80 cents because you can solve our carbon problem. I don't want to argue we should put cola in on their behalf, but we do need to figure out what is the fastest, best way to get out of poverty.
I think you're missing the point. If you look at the way economics work in Africa, that 80-cent number is because you had to haul this line over hill and dale, and the demand is 25 kilowatt hours per person, and so there's a better solution that says right now we're at 80 cents. Hopefully, from the work that Paulina does and I do, we can get the number to 30 in the next couple of years.
All I am saying is the carbon constraint should not slow them down.
This has nothing to do with carbon. I'm
Good.
telling you.
No, that is fine.
Apples to apples comparison.
But so I get your point, but like something to keep in mind is that these communities are also the most at risk from the effects of climate change, right?
Yeah, but that's in many ways our problem, and we owe them that carbon.
Okay.
And so we need to somehow or another fix this. I get this, but it's always very easy to say, and the first time this really got me, well, much earlier I was in Johannesburg and said, you can't solve this problem on this. On the other hand, the New York Times was all upset about the Tata, and the line which got me, if they do that, we are screwed.
But we are.
Because I think you're just mixing two things together. One is the assumption that the only way that Africa can bootstrap itself up is through a fossil fuel
I did
economy.
not say that. I actually don't think so. I don't even think that's right. But what is important is that we do everything to accelerate this process rather than holding it hostage to the climate problem. That is our problem, not theirs. But to come to the China problem, what you see there is they grew they did basically 30 times faster, more than we did, if you look at it from that perspective. That makes perfect sense, because they did it in a third of the time, the development. That's number one. Then there are 5 times more people, so that's a factor 15. And the last factor, too, is very typical in this situation. If you grow that fast, you're going to be horribly inefficient, and you have to keep this in mind here, too. China has been horribly inefficient in its energy system, and it's gradually cleaning this up. And this is a perfectly normal outcome of growing up rapidly. I'm the generation in Germany who said, why didn't you fix all the problems we had in 1945 when you had a chance, because it was all flat? The answer is we did exactly what we knew how to do, because we can do it in a hurry, and we made all the old mistakes a second time, and we knew we were making them because we didn't have time to wait. And that's what's happening in Africa too. You have to give them a chance to do that.
Okay, so we have about 5 minutes left, and we have a few tents. And I know Steve wants a little time before the break to be able to queue up the next session. So we're going to go over to this side, and I think we're going to have to go quicker here. Let's go to Sally first. Yes, thank you.
All right, thanks for bringing this up. I think it's really, really important. And there have been all these experiments of providing electrification, and that's great, you know, through mini grids or, you know, simple solar lighting systems. But what people are finding is that the benefits, the economic benefits that one would expect or hope would come out of this really aren't happening. You basically have poor people living in very difficult conditions who have electricity. So I think if we're really going to try to make some progress on the developing world, I want to go back to support a point you made, that we need to figure out what kind of energy system can be built that will support economic development. And we need to look at those industries in these countries that typically do support economic development. So that's agriculture. Actually, lots of agriculture is quite fossil fuel intensive. Mining is another big one, you know, hugely energy intensive. Textiles, also very energy intensive, particularly if you start providing the higher value added products, meaning you actually make them into fabrics that you can sell. So I think that the community needs to come together and really work with these countries to figure out what portfolio or assemblage of technologies, supply technologies, can pair with their economic development opportunities to ramp this up. And just expecting that solar mini grids are going to solve the problem for quality of life, it's just not going to happen. So I think there's a huge research opportunity, and I'm glad that you're jumping into that. So that's really a comment. And then I guess the second thing that, I mean, you just look at these numbers and, you know, population growth of the world, the globe is already so stressed. And you know, the idea of adding, you know, another 3 billion people, you know, most of which will be in sub-Saharan Africa, one can only wonder what the benefits might be of accelerated opportunities for women to have more choice and more access to education. That, you know, and maybe the benefits of that would far outweigh all this technology and research. And maybe we should think about that as an addendum to whatever we end up saying.
So 2 things. On that point, there has been evidence that energy access provides a lot of opportunities for women, right? That women and children benefit greatly from energy access project. And then on the other point, so I think the question of mini grids is still, and like so I think this is to what you were saying, it won't be mini grids or the central grid, right? So if 54% of the population is in urban areas, that population is likely going to be served by a central grid. But the rest of the population may have to rely on mini grids. And a lot of the challenges that historically the energy access projects faced was that they were aid driven. So you had a lot of organizations coming in, and this was true also in the water infrastructure, a lot of organizations coming in, building this infrastructure without really engaging the communities or thinking about how the communities could continue operating the systems and continue maintaining the systems. So by the time they left, the systems were remained unused. So I think that the question of whether mini grids can support economic activity is still open, and I think at the margin. I spent a lot of time
Pakistan and India, and you know, again, a little bit of electricity gives you nighttime lighting, which is wonderful. You know, maybe cell phone charging, some better communications, a TV. It doesn't support jobs. And if the communities I visited, asking people, what would be most important, the services that we could provide, and they say opportunities for economic development, jobs, money, bring money into our communities. And until you have the reliable, high quality, high power density that people need to support industry, I think that it's not going to be enough. It's a good start. I'm not saying we don't do it, but it's not going to be enough.
Mini grids do not mean that they can provide good quality services.
Well, you have to have a huge amount of power. You have to have a huge amount of storage.
Some of these communities are actually very small and are very far from the grid. So mini grids may actually initially be the only way they get any system.
Yeah, I'm not arguing against, but it's just if we grow content with the idea that we've solved the problem by saying that we have 100% electrification. I think we're so far from enabling people to have access to education and modernity and quality of life that they're going to aspire to. And
I think your that broad brush answer actually doesn't look at the way real economic development works. Yes, to run a mine you need a lot of power. That power, actually, we did work with McKinsey & Company 7 years ago saying you can completely electrify a mine and you can run it off renewable energy. In a mini grid, you can put in 50 kW in a small village. 50 kW can do a lot of work, and most of
well, but mini grids
no. You have to look at what the real. It is a complex question. It's probably worth some academic work. But look, if you're running a mill, lathes, welders, all those things, and you're not running a 24/7 operation, there's ways with the right price signals you can really sweat that asset and still allow people at night to use lights, inductive cookers, and things like that. And so I think having a
large systems, this is a large investment. I mean, I agree with you. I think those are the kind of solutions that people need.
But they're not. I mean, Tanzania is very sparsely populated. So the mini grids that are being developed in Tanzania are in villages that are far from the grid, and they're 30 to 100 customers. So you're not going to build a like a coal power plant or a...
There's nothing wrong with that.
I'm totally missing. My point was we need to figure out a portfolio, wind, solar, whatever other backups, and think about the whole package that is able to support development.
But the portfolio may also be, some places have a central grid that rely on large generation, and some places rely on smaller systems that are not connected to a central grid.
So you don't have to have 1 million watts at your fingertips to develop economically. This country didn't have it when it started. It just didn't. And so 50 kW in a village of 50 families can do a hell of a lot to, pump water so you have time to do other things, to drive a lathe, to do productive labor, threshing, mill grinding. They don't have any opportunity. This country didn't go from, hey, you're working on the land and you're threshing by hand to Google overnight. You've got to have a pathway to get there, and you've got to match the energy system to go with it.
No, they had the Tennessee Valley Authority.
Pardon?
We had the Tennessee Valley Authority. I mean, there was a lot of government subsidy. Anyway, I'm talking about...
Guys, I think that this is awesome. We could go on for quite a while on this.
Yeah.
And we're now into break time, so what I suggest we do is take the remaining flags, if that's all right, quickly. And then Steve. Yeah, okay, so...
Okay, I just like to remind that the inherent danger in implicitly using United States of the Western world as a model for the developing world. When I see the figure on the vehicle per person, the first thing I come to mind is, what is a vehicle? Does it have to be a car? Because if you can see a bicycle, or especially when I pay attention to China, they have the most successful electrification of vehicle. I don't mean car. I mean electric bike and scooter. They have 200 million already running. But I guess that even the Chinese government kind of implicitly assumes that American is the model. So they have the subsidy. They try to promote electric car, and they put in policy try to get rid of electric bike. But the electric bike and electric scooter industry kind of prosper against the Chinese government's restriction. It's very interesting. I think a lot of this, if they are more confident to promote their model or try to work out to perfect their model, they could be make a much greater contribution to the world. But right now, it's they just want to become more like America. It's just like that's it's kind of sad.
So motorcycles are really interesting.
Yeah.
So the only place that I know they have had a successful electric motorcycle fleet is in China. Everywhere else in the world, the fleet of motorcycles is growing, and they're horribly inefficient and horribly polluting. So I am actually very interested about electric motorcycles and their role in these communities.
So three very quick comments. First, to cause, I didn't mean any connotation of good or bad for the growth. Just it's big. It's just that it's big. That's Just and it makes sense. It makes total sense that it's big, and so dangerously big that if that comes across very quickly in other parts of the world, how to accommodate all of that.
Africa will do this 3 times bigger.
So
probably in a third of the time.
So to add to that, actually, to Africa doing that 3 times bigger, it may be a small addition to that problem related to the U.S. crumbling infrastructure and the need for that too. So one more thing to pile on. But the other argument, and building on Sally's comments of the attribute of portfolios, so we've looked a little bit about the provision of services and adequacy depending on the resources available and the cost. I guess that the third thing is also that the different projects will have considerably different lifetimes. And so are we providing a quick fix or a solution that can be lasting for a longer time? So in that sort of developing plan for the portfolio of technologies to include also that aspect of the lifetime related, like comparing PVs to something else, there are tremendous difference, that's all.
Yeah, just a quick comment on this exchange that I think started with Klaus. When we think about economic development and economic growth, we really want to look at the distribution of wealth, because there's a really important tension, which is, for example, what to do with international development assistance. And there are a lot of people in power in the poorest nations that would argue that we should use that to build a more reliable electricity supply. But many development economists would say, no, actually what you need to do is to have use that funding to expand energy access. And so I just wanted to put on the table that we shouldn't be thinking about communities themselves paying for microgrids versus them paying for expansion of the grid infrastructure overall. There are many historical examples, including in this country, where the government really stepped up and paid for expansion of the grid. And I think it's just a very delicate balance that multinationals have been trying to reach for a very long time, of listening to local priorities and what people on the ground want to do, what people in power and communities want to do with international development assistance, while also thinking about these issues of equitable distribution of wealth and where that money should really go. So it's just a very complicated issue, and the same people shouldn't necessarily or wouldn't necessarily be paying for grid expansion versus the development of microgrids.
I mean, it's probably not one or the other, right? There are places, right. Africa is a massive continent. I mean, have you looked at the maps that show you what fits within Africa? It fits like China, the US, all of Europe and India within Africa. So there are places where the grid is just not going to make it.
Yeah, and I mean, my comment is really about the poorest nation. I mean, there's a huge, the per capita wealth is very, it's distributed very unevenly across sub-Saharan Africa, even on that continent.
Okay, thank you. Steve's going to finish this up.
Okay, so we're going to go out to break in just a moment, and we're going to reconvene despite what your schedule says here, at 4:15, just so we have ample time. But what I wanted to do was take a minute and tell you about what the organizers and I have been talking about, what this afternoon and tomorrow morning is going to be all about. And so we kind of have thought through this a little bit and decided that it might help focus the different topics that we're going to discuss and foster some group discussion to, instead of having the groups of rapporteurs report back in these 10-minute blocks tomorrow, start this afternoon with maybe the three of us sitting here at the front table and being more Socratic about this, kind of asking key questions that we would like answered to the different groups of rapporteurs, and at which point, if those rapporteurs need to call upon the experts that actually spoke, they can do that, and we can have sort of a topically shifting discussion. So.
I think the idea is a general discussion, but maybe let the rapporteurs talk first.
Okay. So if you want to maybe gather with your rapporteur groups over the break and get some thoughts together, that would be fine. But
we'll start with the section of those.
yes. So I think we'll start out by discussing what was, lost my paper here.
We said storage and
Yeah. So yeah, we kind of have some categories, and then there's cross-cutting sections. But the sort of dispatchable low-carbon generation would be maybe the first thing we'll tackle. Moving on to different kinds of storage, industrial applications, negative emissions, and then kind of cross-cutting systems issues.
today we'll probably discuss the low carbon generation and maybe storage.
Yeah. And the rest tomorrow.
Right, that's tomorrow morning.
So you have a break until 4:15, and maybe you can meet up with your rapporteur group and chat about what you're thinking.
Yeah, and I guess part of the issue is we want to get back to these things of what are the barriers, what can be done to address these barriers, and not all of the speakers address those points, and so the rapporteurs haven't gathered that information. So you might just want to talk about and think about what are the barriers and what can be done to address them, even if the speakers didn't address them.